Stainless steel is a suitable material for electrical raceways, particularly in demanding environments. Let's examine using stainless steel tubing as an electrical raceway in dairy processing facilities, focusing on low voltage control, 120 volt and 480 volt circuits. A key advantage is corrosion resistance. Stainless steel is highly resistant to corrosion, making it ideal for harsh environments like dairy processing facilities, where exposure to cleaning chemicals and moisture is common. Stainless steel is easy to clean and maintain, which reduces the risk of contamination, a crucial factor in food processing plants. Stainless steel is a strong and durable material able to withstand high temperatures and mechanical stresses, ensuring a long service life. Stainless steel has a clean and modern appearance, which may be desirable in certain applications where aesthetics are important. However, there are also disadvantages to consider. Stainless steel is more expensive than polyvinyl chloride-coated galvanized rigid steel. Welded joints require specialized skills and equipment, which increases installation time and cost. Stainless steel tubing is not as flexible as polyvinyl chloride or galvanized rigid steel, making it more difficult to route through complex pathways. Stainless steel is a conductor of electricity, so it must be properly grounded to prevent electrical hazards. There are a limited number of specific products available for stainless steel electrical raceway applications. Stainless steel conduit. Threaded or welded stainless steel conduit systems are designed for electrical wiring. Stainless steel electrical enclosures include hinged door boxes and other enclosures made of stainless steel for mounting equipment and devices. Stainless steel fittings include connectors, elbows, and other fittings specifically designed for use with stainless steel raceway. Consider the following factors for use in dairy processing facilities. Ensure that the stainless steel raceway can be cleaned and sanitized without compromising its integrity. Select the appropriate grade and type of stainless steel to ensure it is suitable for the corrosive environment. Provide proper grounding to prevent electrical hazards. Weld joints properly to maintain the corrosion resistance and electrical continuity of the raceway. Regularly inspect and maintain the raceway to ensure it remains in good condition and meets the required standards. Now let's dive deeper into each of these aspects. Selecting the right type of stainless steel is critical for corrosion resistance. Several grades of stainless steel are commonly used, each with varying levels of resistance to different corrosive agents. Type 304 stainless steel is a general-purpose stainless steel that offers good corrosion resistance to a wide range of chemicals and environments. Type 316 stainless steel contains molybdenum, which enhances its corrosion resistance, particularly against chlorides. This makes it suitable for environments where exposure to salt or other chloride-containing substances is likely. Type 316L stainless steel is a low-carbon version of Type 316, further improving its resistance to corrosion after welding. When choosing stainless steel, consider the specific chemicals and cleaning agents used in the dairy processing facility. High concentrations of acids, alkalis, or sanitizing agents can accelerate corrosion if the wrong type of stainless steel is used. Consult with a materials engineer or corrosion specialist to determine the most appropriate grade for your application. Grounding is essential for preventing electrical hazards. Stainless steel is a conductive material, and without proper grounding, electrical faults can create dangerous conditions. The National Electrical Code, or NEC, Article 250 provides detailed requirements for grounding electrical systems. The grounding system should ensure a low impedance path for fault currents to return to the source, which facilitates the operation of overcurrent protection devices such as circuit breakers or fuses. Grounding can be achieved by bonding the stainless steel raceway to the building's grounding electrode system using appropriate grounding conductors and connectors. All components of the stainless steel raceway system, including conduit, enclosures, and fittings, must be properly bonded together to create a continuous ground path. Regularly inspect the grounding connections to ensure they are tight and free from corrosion. Corrosion can compromise the effectiveness of the grounding system, so take measures to protect the connections. Installation techniques are vital for maintaining the integrity of the stainless steel raceway. Welding is a common method for joining stainless steel conduit and fittings, but it must be performed correctly to avoid compromising corrosion resistance. Use qualified welders who are experienced in welding stainless steel. Choose the appropriate welding process such as gas tungsten arc welding, or GTAW, also known as tungsten inert gas, or TIG, welding, to minimize heat input and prevent sensitization of the stainless steel. Sensitization occurs when chromium carbides precipitate at the grain boundaries, which reduces the chromium content and makes the stainless steel more susceptible to corrosion. After welding, clean the weld joints thoroughly to remove any slag or discoloration. Passivation is a process that can be used to restore the chromium oxide layer on the surface of the stainless steel, further enhancing its corrosion resistance. If threaded connections are used, apply a suitable thread sealant or lubricant that is compatible with stainless steel to prevent galling and ensure a tight seal. Proper support and spacing of the stainless steel raceway are also important to prevent sagging or damage. Follow the manufacturer's recommendations for support spacing and use appropriate hangers and supports that are made of stainless steel or other compatible materials. Regular inspection and maintenance are necessary to ensure the long-term reliability of the stainless steel raceway system. Conduct visual inspections to check for signs of corrosion, damage, or loose connections. Pay particular attention to weld joints, threaded connections, and areas where the raceway may be exposed to moisture or chemicals. Clean the stainless steel raceway regularly using appropriate cleaning agents and techniques. Avoid using abrasive cleaners or brushes that could scratch the surface and compromise the corrosion resistance. Repair any damage or corrosion promptly to prevent further deterioration. Replace any components that are severely corroded or damaged. Keep records of all inspections, maintenance, and repairs to track the condition of the stainless steel raceway system over time. Now let's consider specific products for stainless steel electrical raceways in more detail. Stainless steel conduit is available in various sizes and schedules, similar to galvanized rigid steel conduit. Choose the appropriate size and schedule based on the number and size of conductors to be installed. Stainless steel conduit can be threaded or welded, depending on the application requirements. Threaded conduit is easier to install and modify, but welded conduit offers better corrosion resistance. Stainless steel electrical enclosures are used to house electrical components such as junction boxes, control panels, and disconnect switches. These enclosures are typically made of Type 304 or Type 316 stainless steel and are designed to provide protection against moisture, dust, and other environmental factors. Choose enclosures that are rated for the specific environment in which they will be installed, such as National Electrical Manufacturers Association or NEMA Type 4X enclosures for wet locations or NEMA Type 7 enclosures for hazardous locations. Stainless steel fittings are used to connect conduit, enclosures, and other components of the raceway system. These fittings are available in a variety of configurations, including couplings, elbows, T's, and connectors. Choose fittings that are specifically designed for use with stainless steel conduit and that are compatible with the type of connection being used, such as threaded or welded. In dairy processing facilities, hygiene is of utmost importance. Design the stainless steel raceway system to minimize the accumulation of dirt and debris. Avoid using sharp corners or crevices where bacteria can grow. Use smooth, continuous wells to eliminate gaps or cracks where contaminants can accumulate. Slope the raceway system to allow for drainage of water and cleaning solutions. Install cleanouts or access points to facilitate cleaning and inspection. Consider the use of stainless steel cable trays or ladder racks to support cables and wiring. These systems can be designed to be easily cleaned and sanitized. Ensure that all components of the stainless steel raceway system are accessible for cleaning and maintenance. Provide adequate clearance around equipment and structures to allow for easy access. Train personnel on proper cleaning and sanitization procedures to maintain the integrity of the stainless steel raceway system. In addition to the considerations mentioned above, it is also important to comply with all applicable codes and standards. The National Electrical Code, or NEC, provides comprehensive requirements for the installation of electrical systems, including raceways. The NEC covers topics such as grounding, bonding, conductor fill, and support. Consult with a qualified electrical engineer or contractor to ensure that the stainless steel raceway system meets all applicable requirements. In some cases, local building codes or regulations may have additional requirements for electrical installations in dairy processing facilities. Be sure to check with the local authorities to determine if any additional requirements apply. Document the design, installation, and maintenance of the stainless steel raceway system. Keep records of all materials used, welding procedures, grounding tests, and inspection results. This documentation will be helpful for future maintenance and troubleshooting. It can also be used to demonstrate compliance with applicable codes and standards. Consider the life cycle cost of the stainless steel raceway system. While the initial costs may be higher than that of other materials, the long-term benefits of corrosion resistance and durability can result in lower maintenance costs and a longer service life. Evaluate the total cost of ownership, including materials, installation, maintenance, and replacement, to determine the most cost-effective solution for your application. In conclusion, stainless steel tubing can be a suitable choice for electrical raceways and dairy processing facilities due to its corrosion resistance and durability. However, the high cost and installation complexity should be carefully considered. Specific products for this application are limited, but they can provide the necessary components to create a safe and reliable electrical system. Proper selection of materials, grounding, installation techniques, and maintenance practices are essential to ensure the long-term performance of the stainless steel raceway system. By following these guidelines, you can create an electrical system that is both safe and reliable. Also, note that continuous improvement is key for optimizing the design and performance of stainless steel electrical raceways. Stay up to date with the latest technologies, materials, and best practices. Attend industry conferences, read technical publications, and consult with experts to learn about new developments. Use feedback from operators and maintenance personnel to identify areas for improvement. Regularly review the design and maintenance procedures to ensure they are still effective and efficient. Consider implementing a predictive maintenance program to identify potential problems before they occur. This can help prevent costly downtime and extend the life of the stainless steel raceway system. Remember, safety should always be the top priority. Ensure that all electrical work is performed by qualified personnel who are trained in safe work practices. Follow all applicable safety regulations and procedures. Use appropriate personal protective equipment such as gloves, safety glasses, and hearing protection. Lock out and tag out electrical circuits before performing any maintenance or repairs. Properly dispose of any hazardous materials such as used welding rods or cleaning solutions. By prioritizing safety, you can protect workers and prevent accidents. Also, the integration with other systems is crucial. Consider how the stainless steel raceway system will integrate with other systems in the dairy processing facility, such as the process control system, the lighting system, and the fire alarm system. Coordinate the design and installation of the raceway system with the other systems to ensure compatibility and avoid conflicts. Use a building information modeling, or BIM, system to create a three-dimensional model of the facility. This can help identify potential clashes and coordination issues before they occur. Work closely with other trades such as mechanical contractors and plumbers to ensure that the raceway system is properly installed and integrated with the other systems. Proper documentation and labeling are critical for efficient maintenance and troubleshooting. Label all components of the stainless steel raceway system, including conduit, enclosures, and fittings. Use clear and concise labels that are easy to read. Create a detailed drawing or schematic of the raceway system showing the location of all components and the wiring connections. Keep the documentation up to date and readily accessible to maintenance personnel. Use a computerized maintenance management system, or CMMS, to track maintenance activities and manage spare parts. Regularly back up the CMMS data to prevent data loss. Consider the use of remote monitoring and control systems to monitor the performance of the electrical system and detect potential problems. These systems can provide real-time data on voltage, current, and temperature. They can also be used to remotely control equipment and adjust settings. Remote monitoring and control systems can help improve the efficiency and reliability of the electrical system. In addition to the technical aspects, it is also important to consider the environmental impact of the stainless steel raceway system. Stainless steel is a recyclable material, so be sure to recycle any scrap or waste. Use energy-efficient lighting and equipment to reduce the overall energy consumption of the dairy processing facility. Consider the use of renewable energy sources such as solar or wind power to further reduce the environmental impact. Implement a waste reduction program to minimize the amount of waste generated by the dairy processing facility. By considering the environmental impact, you can create a more sustainable dairy processing operation. The information is provided for informational purposes only. Consult with a qualified professional before making any decisions about electrical systems.